Good evening. Welcome to the USC Architecture Public Event Series, Fall 2020. Very pleased this evening to have a very prominent structural engineer with us. And I want to start by thanking him for coming, being with us, and also bringing his thoughts to us this evening. I'm Milton Curry, Dean of the School of Architecture at USC. USC Architecture is an emerging premier design school, a global platform for instruction, research, creative production on cultural heritage, cities, landscapes, architecture and urbanism, buildings and technologies, histories and theories about the built and design environment at all scales. Very pleased today to focus on design, aesthetics, and structural engineering with Dr. Rezai, a structural engineer, a visionary designer, and educator coming to us from Singapore. One of the initiators of the concept of fusion engineering, he is the first and only engineer to receive the coveted title of Designer of the Year from the President of Singapore. He's very passionate about the process of advanced computational design and a holistic approach to architecture, structure, and the environment. Dr. Rezai's high-profile contributions to industry discourse include his involvement in the 13th cycle Aga Khan Award for Architecture's Master Jury in 2016, as a jury member for the Singapore President's Design Award 2017 to 2018, and as vice chair of that organization 2019 to 2020. Dr. Rezai is the founding director of Web Structures and Web Earth. His latest initiative on advanced computational design aims to redefine the collaborative nature of designers working with machines to overcome the compound challenges faced by the building industries and the environments within which they're deployed. Dr. Rezai is a prominent proponent of high-rise and dense urban development with emphasis on innovative structural systems for tall, super tall, and mega tall structures. He obtained his PhD from the University of Westminster. Dr. Rezai, it's great to have you with us. We welcome you. We'll be joined by Dr. Bhavna Sharma on our faculty at USC in the Q&A, but I want to welcome you to the USC Public Event Series. Thank you.
Thank you, Dean Curry, for that introduction, and good evening, everyone. Thank you for the invitation. I will be spending the next half an hour or so sharing with you some provocation on an ambition that I have, and I know quite a lot of us share that, and that is to try and move towards the ideal of having a planet for all species. The presentation will be sort of in 6 parts. I will share some projects to show, to set the tone and to see what the flavor of the type of work that we have done in the past 25 years, not only to deliver projects, but also to see how we have moved towards achieving these ideals of justice on the planet, environmental justice and social justice. I will then share some ideas about the contrast between the natural environment and the built environment, and talk about the concept of multiplicity of clients, and then see towards the end how we can achieve these high ambitions through harnessing the power of technology and, as Dean Curry said, sort of something that I'm very passionate about, advanced computational design, etc. In the way of introduction, I share some of the images of some of the projects that we have worked on. We've been working as structural engineers and environmental consultants on over 700 projects for the past 25 years across 28 different countries. This is the St. Regis resort in the Maldives, which we worked on with WOW architects, both Wong Chu-man and Maria Warner Wong, the founding partners of WOW, are amongst the distinguished alumni of USC. And I'm very proud to have been working with them on this and a number of other projects. Notice the sort of organic shape of the whale bar and the library on the island. The building on the right is a high-rise project of Ardmore residence that we worked on with UN Studio at 3 stories, inter-story blocks, interlocked together and sat across 30 stories stacked on top of one another. A bamboo installation in Malaysia using bamboo and the structural system of reciprocal framing that we learned from one Leonardo da Vinci. Headquarters of Media Corp, a competition-winning scheme in Singapore with Maki and Associate out of Tokyo and DP Architects. Again, if you notice the organic and curved shape of the building, which responds to the context of the site and the neighborhood. Capella Resort on Sentosa Island off Singapore with Foster and Partners. This is a factory building we did in Penang. Factory, we call it factory in the forest. In a forest, it is one of the most environmentally responsive factory buildings anywhere. Going back some time, Four Seasons Resort in Siam Terraces in Ubud in Bali. For me, it is an epitome of an built environment, a building which is integrated fully with the natural environment. It's a tall building we worked on in Thailand, Pattaya by the beach. It's I'm sharing it with you here because the architect of it is one Hans Brauer of HP Design, another alumni of USC. A project about to finish in Kolkata, the Atmosphere, with this sort of a rooftop bridge across in a seismic area and with reasonably high wind speed, and the way this has been sort of isolated from the rest of the building. The Asia School of Business in Kuala Lumpur, the curved and organic roofs that respond to the environment and how light penetrates through the building, through the roof into the atrium below. One of the tallest buildings in the world, if it was built, but we worked on it for about a year with Woods Baggett and DP Architects, with Patrick Daly, a dear friend of mine, and I know of Dean Curry's as well. The last couple of projects, a building under construction in Dhaka, a university, BRAC University campus with Waha Architects. One of the structure of this building has one of the smallest embodied carbon footprint square meters of the real estate. Headquarters of Viettel in Hanoi, again the horseshoe shaped and organic shaped of the building, sort of creating the context on an island site in the city. Airport Control Tower with Richard Rogers' office, RSHP in Taipei. This is a competition entry. And I think finally, the headquarters of Tokyo Marine Insurance in Singapore, with these exoskeletal, apparently randomly running chopsticks around the perimeter of the building, but there are structural logic as to why they are doing what they're doing. Generally, a series of 700 projects across 28 different countries. But these are, we have used them obviously as not only as delivering to our clients, but also as tools and means in order to be achieving that higher goals that we have towards achieving justice in our on our planet, just social justice within our own species, and interspecies justice, environmental justice, which I would like to talk to you a little bit about. Now, you see, justice and design for me have a lot of things in common. If you are the only person in the room, whatever you do is just. There are obviously many definitions of justice over the past 2,000 or 3,000 years. Philosophers have been talking about justice, and their definition of it is different depending on which class of thought one leans towards. But at the most fundamental level, if you are the only person in the room, whatever you do is just. It's only when there is another person in the room that we need laws in order to regulate the relationship between the two of us. And when there are two people, whatever each one of them does is not just. That's when we need the laws in order to regulate that. So laws are for, in a way, to bring in order amongst us. And they're not necessarily working towards justice, but they're working towards order. A similar idea for me exists in design. So if you have only one object, if you have only one choice, then in a way there is a singularity, because whoever is the designer, there's only one decision to make, so everybody's design will be the same. It's only when we have choices, if we have two objects, for instance, then one designer might lean them against one another. Another one might put one in front of the other. Another one might put one side by side. So design starts happening. So it is the parallels between justice and design in this sense, that is something that I have been sort of engaging myself with, and to see how, as designers, engineers, architects, town planners, etc., we can not only deliver our projects, which is the tools, I would say the tools of our work, but also to try and achieve justice. One of the proponents of this sort of approach to design is one of my favorite architects, Richard Rogers. And his latest book, which came out in 2017, A Place for All People, is one that I highly recommend to any student of architecture or design, and to any person who is engaged with the idea of design and with the idea of justice. It is an autobiography of Richard's, but it is a personal autobiography as well as a professional one. So I highly recommend it. I'll come back to this right at the end of the talk, just to remind you that A Place for All People was Rogers and Piano's tagline for the competition entry for the famous Pompidou Center, A Place for All People. One sentence in this book that has really stuck in my head to dealing with justice is where he presents the court building that they did in France. And in that, the chapter starts by saying that there is more to justice than the law. And that is a very poignant point for me, which I wanted to share with you. In section 3, how do we sort of achieve justice while doing work that we all have? One of these ideas, concepts in my head, and it's been nothing other people have thought about it as well, I'm sure, is the concept of multiplicity of clients. You see, what we have, and staying with the theme of Pompidou and Richard Rogers as an example, see, we usually have a project, a client, a paying client comes with a cite a brief, and ideally some money to deliver a project. We have that as one client. The site and the paying client is one of our clients, and it is our duty of care, and we have contractual obligations towards that client to achieve his ambitions. Whatever his ambitions are, if we have taken the project, we ought to apply ourselves to ensure that he achieves his ambitions. If we think that we're not aligned with his ambitions, we won't take the project. If we took it, ethically, contractually, legally, we have to help him achieve those. But that is not the only client that we have. Most of us unfortunately think that once we deliver the building, that is it. We just work with the brief, the authorities, etc., and deliver the project within time or within budget, etc., etc. But on top of that, I believe that we also have about 9 other clients. One of them is the street. So the streets around the site are our clients. We have a duty of care to the street to make sure that our work on the site enhances the street. So the streets are better streets than they were before we delivered our project. The neighborhood, all these buildings around the neighborhood and the people around there, they're our clients. We have a duty of care to them to ensure that the neighborhood is lifted, is enhanced as a result of our work, rather than it being diminished. The grid of the city is our client. We need to have a look at the grid of the city to see where there are any breakage in it, if we can repair it through the influence of the project and the site that we have. The city is our client. The city of Bilbao is put back on the map with sort of one project, and as it happens with one of the alumni of USC, as it happens. So the city is our client. You have to see that the whole country is our client. The country of Singapore, by moving in one direction, having a groundbreaking building project, whether it is environmentally groundbreaking, etc., it sort of enhances the valor of the country internationally, that, you know, these guys have arrived. They are not only looking at buildings as buildings, but also buildings as things that represents the country. Going back even higher, I think the whole planet is our client. So when we say we are environmentally responsible and environmentally responsive, it means that we should take as if the planet is our client, and we are taking care of the interests of the planet. All the way from the planet down back to a tree, which is on our site or around the site, is our client. The 2 birds which have nests on those trees are our clients, and it is getting even more emotive, but I think the psyche has got to be there. From the planet all the way down to this ladybird is our client. If we approach our projects with this attitude, then we will take care of the ladybird, biodiversity. We will take care of the environment, the planet. We will take care of the city and the neighborhood. So this is like a concept of multiplicity of clients, which we ought to bear in mind. Some of these guys, like the paying clients, have an army of project managers and lawyers to take care of their interests and interact with us. Others don't have, and we should take it up on our shoulders to take care of the interests of all of these guys. The next provocation, I suppose, is it's a discussion on the natural environment and versus the built environment, and see how the contrast exists between these two, and how we can, through our work, in my case, structural engineering, in yours, maybe architecture and others, how we can close the gap between these two. You see, when you look at the nature, you see a symphony of colors, see a multiplicity of shapes and forms. Every tree leaf is different. Every bit of every root of every building is different. different. Everything is exactly the size that it needs to be. No, not bigger, not smaller. There is a richness of form and a tremendous frugality in use of materials. In contrast, when we look at our built environment, we see that everything is vertical, everything is horizontal. Every floor plate is either square or rectangle, unless it is triangular. Very, very poor in shapes and forms. And in return, it comes with a wastage of material. Everything is standardized. Every time you standardize, you're wasting material. And this is not something that applies to our modern cities. Our older cities, or for thousands of years that we've been building cities, we've been following the same things. There are reasons why we've been doing it, but I think it is good for us to reflect back and see what is the contrast between the built environment and the natural environment. And when you put these two images together, on the left, the natural environment, on the right, the city, I put it to you that a number of environmental challenges that we are all grappling with rests in the contrast between these two images. On the left, the concept of waste does not exist. On the right, the desired outcome, which is a building, always come with at least one order of magnitude higher undesired outcome, which is waste. It is integral in our processes. And what we need to do as part of our endeavors to achieve environmental justice, to achieve environmental congruity, is to try and move the image on the left, on the right, the built environment, as close as we possibly can to the image on the left. Our future cities should look more like the image on the left than the image on the right. And as much of that as we can achieve, and the more congruent we can be with the environment, the more we can mimic it, then the less of these current challenges that we have will be with us. Now, how can we do all these things? It is tough enough for those of us who are practicing professionals, architects, engineers, etc. It's tough enough to deliver one project and to satisfy the demands and needs of one client, together with the statutory requirements, authorities, etc., etc. How can we load ourselves up, set ourselves such high levels of challenges as 9 other clients, and then try and become congruent with the environment and get closer to that image, etc., etc. I think it is possible by harnessing the power of technology. It's a topic that I am very, very passionate about. The advanced computational techniques and tools, and I would not even call them tools, some sort of collaborators, will enable us to be setting these high ambitions for ourselves and hopefully achieving it. And to some extent, that is what we have done through some of the projects that I've shared with you. Efficiency and, in fact, justice in use of material has now got an aesthetics. The aesthetics is that of the nature. This image is the image which looks like an X-ray of a bone structure, is in fact the structural frame for a 50-story building in China. There are 1, 2, 3, 4. There are eight options. If the brief for that project was given to nature, and if this building grew out of the ground, the structural frame would look something like one of these. The white areas are where the higher stresses and force demand exist. That is where you would put structure, you would put bone. The black areas are areas where there is no demand on the structure, so there would be none. And the different shades of gray would receive that different levels of structure and material. This is that building. What the black one is the structure, could be the structural frame for a building which looks like this. The exoskeletal, if you like, or the X-ray of the structural frame for the building when folded. Looks like this through topological analysis. And then the way we would take that structure and provide more where the white areas exist, the grillage, the amount of material is more in the white areas and less in the black areas. So every building, every structure that you see has got a standard diagonal grid across the entire frame and everywhere. That is a waste. There is no demand. Rarely, if ever, do you have uniform demand on the structure across the entire structure. I'm moving on to the next slide. So on the left is a topologically derived frame. In the middle is is sort of with the sort of thing that we are now capable of doing in terms of provision of materials where it's needed. And on the extreme right is the actual image of the building together with this sort of outer tube structure. A study that we did on, this is a case study that we did on the Park Avenue, 432 Park Avenue. It's not one of our projects, but we as a research, we looked at it. You can see it's a square building, 28 meters by 28 meters on plan, extruded up and very, to sort of 426 meters, a highly squarish building, as it is a very slender height over width of 15.2 meters. When you analyze this structure, you find that without any dampers, at the top, due to wind, the top of the building, if you didn't have any dampers, it would move by about 1.4 meters. What we did, we looked at, and the material usage is 1.8 million kilonewton of material used for the structure. If you topologically came up with a frame for it, you would get one of these sort of images that you see in here. Again, the skeleton, the white areas being where the structure is needed. And if you then analyze this and converted it into the sort of thing that we can build now, you end up with these sort of images. You move away from purely vertical and purely horizontal elements. Diagonal elements start appearing in the image. And when you analyze the structural frame derived from here, you see that under the same wind speed on the left-hand side, the top movement is now reduced to 797 millimeters, as opposed to 1,385 millimeters of the original building. So it is about 60% more rigid, more sort of stiffer, it's more efficient. And when you look at the use of the material, you see that it is sort of about 7-8% less material used. But the performance in the summary, 66% improvement to lateral drift of the structure. So you can use the same amount of material, get a structure which is 66% better in terms of performance, or reduce the amount of material usage to achieve the same level of performance. So efficient looks like this. When you see things which are purely vertical, purely horizontal, they're not efficient. The project that competition win that we are currently working on with Zaha Hadid's office in Singapore, a museum. It has sort of what we call 5 bars, long elements, 1, 2, 3, 4, 5 in here. We looked at the 5 bars. This is how it was determined by the architects initially. We did an energy analysis on the structure and said, what if we shifted some of these elements and twisted some of them on plan, and what level of efficiency would be achieved? And the studies, I hope you can see the animation, the amount of rotation that could go on, or shifts in X or Y direction. The eventual analysis showed that if you could see the sort of green shaded elements are the original layout, and the red one and white one and on the side is the proposed amendment adjustment to it. Tiny adjustments, but it improves the efficiency by 17.8%. It is so when we move from the randomness into mathematical study and achieve congruity with nature through the wisdom of nature, which is mathematics and is computational design, you can achieve tremendous amount of efficiencies without a lot of adjustment and change, in fact, in this case. So the structural frame coming from for one of these bars, which is like a box structure, would look like this if, again, if nature built it, if this thing came out or grew out of the ground, it would look like this. You can see the sort of images in nature, but then we try and provide elements of structure as close in fidelity with this image as we possibly can, rather than starting with a standard grillage and then trying to adjust that. A couple of tall buildings I share with you. This is a building under construction in Kuala Lumpur, 58 stories, 62 stories, and a 72 stories building. The two 58 and 62 story buildings on the right twist away from one another as they go up. And the twisting is done in order for the units from one tower not to look into the units of in the other tower. It's a very rational and logical reason for the twisting. In the event the buildings are actually twisted, this is curved as they go up. The analysis is done the optimization technique which was used develops structural solutions which are multiple solutions. Like in this image, every screen freeze is a valid structural system. So what you've looked at now, I hope it is coming through at the other end, is say about 800 options. Now, if you have 800 options, you're more likely to choose the most efficient one, as opposed to one option, where if you don't have one, or 5 options. So these tools will enable us to be doing these things. Other techniques that we're using, what we call structural neurology. This is sort of, in a way, it is one column. It's a model of one column. At the base, they can join together. At the top, they can join together and becomes a vertical column. As alternatively, they can open up and optimize as we would need them to. Some of the study that we're doing with Singapore University of Technology and Design, the analysis of a complex structure like that can be done with one single material and one single material size. So as complex as this form and this shape is of this complicated column, every element actually is same size as all the others. So by the time it comes to the top, you can see that they're all effectively the same size. So you use one size, but through shape formation, you come up with an efficient system for the desire that you have. I think one of the last projects that I share is a walkway green corridor across Singapore for bicycles, an elevated corridor. And we looked at the sort of structural system for it, the Frey Auto method of tree structure, and how these trees can then become simpler, more complicated. They can start leaning against one another in order to deal with the lateral load they can start getting integrated into one another. And the more you move towards this image, the more congruent you are with the environment, the less material we are using. Of course, shape becomes richer as you see in the environment, and we're getting closer to the mind of nature, which are these images that we see in our natural environment. I think, yes, I'm towards the end of my presentation. Basically, definitely from a structural engineering point of view, we are moving away and maybe sort of evolving, not so much moving away, but evolving from a simple approach to the task of structural engineering being to achieve safety, serviceability, buildability, code compliance. From this sort of rather simple terminologies, we're moving to parametric modeling, conceptual mapping, interactive rendering, simulated reality, topological optimization, digital integration. You know, the terminology is changing with this, the psyche, and our reality needs to change. And it is by harnessing these sort of tools and collaborating with machine at its highest level that we can achieve these higher standards that we are setting for ourselves, that we are not just delivering a building, we're not just building a structure, but we are trying to achieve justice on our planet, social justice and environmental justice. And my last slide, the epilogue. I shared with you A Place for All People, one of my favorite books from one of my favorite architects. He's almost 25 years older than I am, so exactly I'm one generation behind him. So myself and people like me have been highly influenced by Richard and his ideas. A Place for All People was a tagline for Pompidou, as I shared with you. And I think as beautiful as that is, and that was, I think 50 odd years later, we need to move away from that and evolve from a place for all people to a planet for all species. I think our emphasis on people, as good as it may have been, has been somewhat flawed to brought us here. A sort of people-centric design, as interesting and as emotive as it sounds, could be one of the sources of the problems that we've had, where people, us sapiens as one species, have been taken out of the general environment, out of the food chain, and we've come out of it and we have treated the rest of the environment as a resource. I think we need to get back into a situation where we are integrated with it and live in justice with the rest of the species. We're not the only people in the room. We're not the only species on the planet. It is not just for us to do whatever we fancy. We need to take care of the interests of others and move from this and maybe become sort of design-centric people, conscious of the fact that we are not the only people in the room. With that, I thank you.
Thank you, Dr. Rezai, for that talk. My name is Bhavna Sharma, and I'm here to moderate the discussions portion of this evening's lecture. This evening's lecture is made possible by the Nabih Youssef Endowment Lecture on Structural Design Innovation Fund. So I'll start off the discussion session with some questions, while the audience can submit their questions to the Q&A link at the bottom of your screen. So I have lots of questions that I can ask, but I encourage the audience to submit their questions as well. So Dr. Rezai, you talked about aesthetics and efficiency. Many would consider that to be conflicting views between an architect in terms of aesthetics and an engineer in terms of efficiency. So my question to you is, how do you view beauty and efficiency, and how do they intersect in structural design?
Well, that is a perennial challenge that we have. I think without being sounding too idealistic, I think if we set a challenge for ourselves, that the aim of all of us as designers in the built environment is to achieve justice, then there is no conflict. We're all working towards the same aim. If we achieve, set for ourselves the goal that the aim of all of us when we work on a project is to satisfy those 10 clients, then we're all working in line and in tune. It is only when we become develop a myopic view of what it is that we're doing. If we, instead of the 10 clients, we only have one client. Instead of one client, we actually have one project. Instead of one project, I only have to do the structure, and you have to do the architecture, and he has to do the cost. If we go back into our tiny little territories and become protective of that, then obviously conflicts start appearing. I think aesthetics is the job of everybody who's on the project, not only the architect or the interior designer or the engineer or the quantity surveyor. I think cost efficiency is the job of everybody on the project. And if we move from our core areas of competence, which is our mother tongue, the single language that you speak, and speak the language of design, when we overlap together, in that overlap area, everybody is responsible for everything. Once, if you develop the most beautiful and most efficient structure in an architecture which is highly wasteful, then we have all failed. I think it would be that attitude that I would promote, that we are all responsible for everything.
Okay, so let me follow that up with a question about your discussion about the evolution of structural engineering, and sort of your ending slide about how sort of the process of structural engineering is moving beyond sort of traditional reduction of costs and creating an efficient structure and using material in that way. So how does this evolution change the role of architects and the role that they play in the design process?
I think we all need to evolve and move beyond the minimum roles that we have, the minimum levels of responsibility that we have. Obviously, our structures need to continue to remain safe. So safety is still the main responsibility and main thing that the structural engineer brings to the table. Obviously, our buildings need to be buildable, or they just remain images and ideas. So as a structural engineer, we need to make sure that the structures that we design are buildable. They need to be serviceable, and they need to be compliant with codes. Those are, they used to be our ambitions. They're now at the entry level. Every structural engineer comes up with structures which are safe, which are code compliant, which are buildable. You don't see our structures sort of falling down, collapsing right, left, and center. They're all safe. They're not differentiating. The differentiation comes in when you add those additional layers of responsibility, additional layers of ambition upon yourself. Maybe the paying client doesn't want that. The paying client wants the building to be safe and cheap. But the ladybug needs me to be a little bit more ambitious about what material I use. The planet maybe wants something else from me. So in order for me to be able to satisfy all these requirements, I need to move away from the language of safety, serviceability, and buildability. Similarly with architects, I think that architects are responsible for aesthetics is obviously demeaning of the role of the architect. Obviously, definitely no good architect wants to be seen as if they are just aesthetics people, because they're not. They are the authors of the project. You know, they are the only guys who start off a blank sheet of paper. You see, I'm a fantastic structural engineer. I've done, you know, 800-900 projects across the world. I've worked with many, many good architects and things. You give me a blank sheet of paper, I wouldn't know what to do with it. That is not where my core competence is. But you give me a tiny little sketch. The architect, whether it's Wang Chuman or Richard Rogers, they call me and say, you know, we've got this project. I think like this. They just give me an image. I can start working with it. So it's really the full authorship of the whole design rests with architects, and they're way more than obviously being responsible only for about the aesthetics. So their role is obviously a lot more the social responsibility that Richard Rogers talks about in his book. And one of the things that you know we're currently lacking in many other architects who go into the pigeonhole of I'm an architect, I do buildings. No, you know, buildings have to achieve more than just housing people. They need to achieve justice. They need to achieve equity and etc. So everybody's role has changed and has evolved, and we must stay with that and be even more ambitious.
Okay, we have a question from the audience. As we know, designers, artists, and engineers are using tools quite differently. How would you value and balance between engineering, which is simulation driven, and design, which is creativity driven?
Yeah, I think that's a great question. I mean, we talk about creative engineers. Others might disagree and say that actually engineering cannot be creative. At best, it can be innovative. So the difference between innovation and creativity. But I would have thought, you know, beyond those semantics, the contributions that at times we as structural engineers have made on projects where we have not only enabled an idea that the architect, for instance, has come up with through simulation, but we have actually enhanced it by virtue of studying and developing the various systems, some of which I shared with you. And then when we've sort of been in a creative environment with the architects, they've said, oh yeah, well, can we do that? I never thought we could do that. We would like that, but I didn't enjoy it because I didn't think it was possible. You know, this idea that obviously as architects who are the authors, they start off a blank sheet of paper, they have to second guess everybody. When they start, they have to assume that the structural engineer would need a structure of this nature. So as they're drawing it, so that their design is realistic, they assume what sort of the structure might be, they assume what the servicing might be, they assume what the environmental guy might want. All of those assumptions, the first thing that we do when we get that first set of scheduled drawings from the architect, in discussion with them, we destructure the architecture. We remove, we say, well, assume there is no gravity where the structure has to challenge and deal with it. What would you like to see? So it is that discussions with the architects at that very, very early stage of the project that at times you can see they've drawn things that they really did not want it. They thought that we would want it. So that process, whether you call co-creation or whether you call just the engineer simulating and the architect creating, I think it becomes a little bit too close, the divisions. I would say it is more like can be a process of co-creation together.
Okay, we have another question from the audience. How do you balance the ambitions of designing with justice and equitability versus the adversity with clients who just want the cheapest building?
Well, I think that there is that challenge. You see, I have never had a client whom I asked the question, do you care about the environment, who said no. I think everybody cares about environment. I've never had a client that said, do you care about equity, justice? I said, no, I don't care about justice. I just want a building. I think everybody, these are values that exist in all of us. Some of us are more vocal about it. Some of us are more active about it. Others, in others, it is a little bit dormant. I think you can activate that in every client. No client would say that I don't care about justice, I don't care about the environment. And once we establish that we all care about these things, of course we care about your interest as well, which is to maximize your profit by reducing cost. Or maybe we don't go for the cheapest here, but we go with something else that actually gives you more profit, because you don't necessarily want to spend less on the structure. The ultimate for you, Mr. Client, is to have more profit because you're just purely money oriented. Now, if you take that project and I make that provision, sometimes you say, you know what, we're not congruent, we're not aligned, this is not the client I want to work for, and you say no to politely or otherwise. But if you take the project, we have to align our interests, and you find that through communication that the guy doesn't really want the cheapest one, he wants more money out of the project at the end. And so you can give him something that is not necessarily the cheapest, but it gives more value. And it on the side, it also takes care of the ladybug as well. And then we found this experience that with clients, gradually we grow together. The projects take 2, 3, 4 years to come to fruition. So it is not a single transaction. And in that process, we influence each other. And I think if you're passionate enough about some of these issues, if you're reasonably knowledgeable about them, and if you come across as being genuine and put these things to people, rarely do people say, you know what, I don't want any of these things, just give me a building. I've never had that experience.
In my experience, it is an exceptional designer that can help a client envision these concepts in a project. A client sometimes comes to the table and says, I want a building, but they don't know how to articulate their concerns in the areas that you just mentioned. And so it's an exceptional designer who is able to guide them through that process and really highlight the opportunities that are in the design and can achieve those goals as well. I've got another question. How do you see the future of policy laws changing towards spatial justice and environmental justice?
Well, I think, you know, we have a lot of challenges. Numbers don't look very good. The CO2 in the atmosphere, parts per million, is way beyond the number that some people think is sort of reversible. Equity, you know, the situation with equity is terrible. You know, there are numbers that, like the poorest, like 50% of the population in the US collectively have an equity of 0. So if you now have $50 in your pocket, you're richer than the poorest 50% of the population of the US. The numbers are terrible, and US is like the richest country, the most powerful country at the richest time in the history of mankind. 50% of the population have an equity of 0. So the numbers are very bad, but I remain positive. I think a lot of policymakers have already been influenced by this. Some of the discussions that pressure groups would have, I as a younger environmentalist pressure person would do in the 80s and late 70s. Some of the lingo that we would use then, they are into policy. You hear them in the UN, you hear ministers and prime ministers and presidents of most countries, not all countries. They talk that lingo. I think we've made a lot of progress. Policymakers, we've won the argument. If there was two sides to the argument, definitely that inequity exists and we need to deal with it. We've won the argument. That environmental justice did not exist and needs to exist, and how it can exist, we won the argument. It is the implementation and the speed with which that can happen. And of course, you know, the things to do with fossil fuel, the lobbies for that, cost of oil, cost of fossil fuel, etc., which is so artificially low, creates tremendous amount of challenge for us. But I think we have very good policies. We have intergovernmental panels who come up with these policies, and more people are converted and practicing. People are being more conscious of what they eat. People are being more conscious of how they travel. So I think there are a lot of positives, and I mean, we just need to continue to spread the word and continue to enact on some of these convictions that we have. We are the majority. We are the mainstream. We're no longer a pressure group. We are the mainstream.
I have a question to follow up on that, but I'll ask an audience question instead. Have you explored the solar envelope concepts of Ralph Knowles, who taught at USC for many years? It's based on assuring solar access to neighbors in your community. It results in a certain texture to the city. Do you think that we could arrive at an overall aesthetic from such rules and textures that they create?
I'm not familiar with that work in detail, but I can see that, you know, in New York, the planning laws in New York, the right to light, the right to sunlight, planning laws in Shanghai. These ideas have already, you know, justice in the spread of sunlight to neighbors. They've already gone into bylaws, into policies, documents that you know, allows everybody in the neighborhood to share the wealth of light, so, and I would say just that much about it. I don't know enough about that particular work to comment more.
So just coming back to your comments on mainstream design, I'm familiar with that some of your design work includes net zero energy projects. And so the question I was going to ask you is, do you foresee these becoming mainstream because they have an impact not only on the environment in terms of reducing energy consumption based on fossil fuels, but also reducing the power or the cost of power or electricity for the user themselves? So do you foresee these types of projects becoming mainstream in the future?
Yes, I am very optimistic, and I'm very positive about the prospects of zero energy buildings. One of the things that we gained by doing a net zero building, there were these numbers that our environmental guys within Web Earth had developed. You see, if you do all our buildings from now till the end of this century as net zero, all the buildings that we're going to build in the future are designed and built as net zero. We reduce the CO2 that we emit into the atmosphere by something about 17%. 17%. It is good, but it's not good enough. No, 17% is basically, currently we are emitting about 50 gigaton of CO2 per year into the atmosphere. If we don't do anything, continue with the business as usual, it will go up to 65 gigaton. If that 15 gigaton extra is reduced by 17%, it is still a huge number. These measures are good, but they're not good enough. So yes, definitely from our perspective, zero energy buildings are good, but there are 7 or 8 other shifts that we all need to have, and I mentioned some of them. Agriculture, transport, source of energy. You see, if you reduce the source of energy, concrete is the worst environmentally considered material. I don't care about people who talk about green concrete. It is just, you know, it's just a green thin of veneer on top of it. Concrete is the most environmentally damaging material that we can ever use and invent. But then it's also the cheapest material. there is something wrong with the measure, that the scale that we have measured, that it is the cheapest because cost of damaging the environment is zero. If you equate the cost of damaging the environment and convert it into dollar sign and add it to the cost of the concrete as it is now, concrete becomes the most expensive material. Fossil fuel becomes the most expensive material, most expensive source of energy. So I think we need to address those issues as well, to do with the value system that gives the a cost of a barrel of oil at $30 US, $40 US now. Cost of a barrel of Coca-Cola is 400. How can oil be so cheap? It's artificially cheap. The value of concrete remains artificially cheap, and its damage remains high.
We've got another question from the audience regarding the ethics of environmentally responsible design. How might we create greater buy-in in regards to convincing people to adopt ethical, environmentally responsible design practices?
How do we do this?
Yes.
We did a study again with our Web Earth guys. The study was about level of engagement with the environment, levels of engagement with the environment. And we identified, I can't remember all of them, but we identified our levels of engagement with the environment starts with denial. There are climate environment denials that people exist. And then after that or before that is ignorance. For some people who are ignorant, they actually don't know that we have these challenges, the environment. There are people who are aware, but they don't do anything about it. There are people who are aware, but also talk about it. There are awareness and advocacy. Then there are people who are aware, advocate, and take some action. And gradually, so levels of engagement with the environment goes up from either denial or ignorance all the way up to being aware and being at a level that you're either a policymaker or you influence policymakers. But the highest level is that you're aware, you act on it, you advocate, you influence policymakers, but you actually influence the law. We're talking about justice and the law, where it goes into the statute book, that it is no longer the policy of one government or the desire of one individual who comes to power and becomes a policymaker, but it becomes illegal to damage the environment. At that level, you don't even need to know why if you don't want to know why. You jump a red light, you get a ticket. You damage the environment, you get a ticket. Now, whether you know why you shouldn't be damaging, etc., it becomes sort of irrelevant. So it's these levels of engagement with the environment that varies across the globe. And our guys did a study where they look at one city and say like 10% of the population in this particular city are ignorant of the environmental challenges. 15% are aware but do nothing about it. 10% are working on policymakers, etc. And then you look at these things. Different cities have different profiles of this graph of awareness, etc. Different countries have different levels. So, and then in a three-dimensional way, they built up these percentages across these matrix of awareness, and we call it the climate tree. We call it the climate tree. It becomes like a tree structure, and then it really depends on where you are, which city you are in, which country you're in, and which segment of population you're concentrating on. What you need to do will be different, from advocacy, like what I'm doing now, just talking about it, to practicing, like I showed you some of the things that I'm practicing, to working with policymakers, and ultimately working with the lawmakers. And it's sort of, you need to be creative about it, I suppose. And you know, the audience here, I'm sure, are of our highest level of creativity. And we need to be inventive about how we spread the good word, but also through our own action.
I could talk to you all evening about this, but I will reserve my questions for later. So we have another question from the audience. How does racial justice play a role in your work in regards to the community context and also the workers realizing the designs?
I think maybe through definitely working with the workers who work on our projects is the true collaborative nature of the work. You see, everybody matters in the process. This idea that it's my design and I take all the credit for is doesn't work, should not work with architecture. It doesn't work with buildings. You know, architects are maybe perhaps, you know, one of the few art practitioners of art forms who do not actually create their own art piece. Sculptors produce their own work. Painters and artists, they produce their own work. But our buildings are produced by other people. So the work that people do to build these buildings, from a bricklayer all the way down to the guy who casts the concrete or the one who paints the wall, his work is just as important in achieving that perfection that we want in our work as my thoughts and my drawings and the architect's ideas. You know, if you can come up with great ideas, but you know, by the time the product has come out, it may not live up to that. So definitely truly believing in and not just talking about it. The fact that this is a collaborative work. Everybody's work and everybody's input matters. And sort of see engaging everybody in the process and engaging everybody in the benefits, publicity, you know, engagement with the benefits of the project is brings in an element of justice, obviously, into our work. As for racial justice, I think, you know, we ought to be really aiming at that ultimate justice. And if you move towards that ultimate justice, then we will have sexual justice, racial justice, diversity, and all.
So we'll take one final question. The audience member asks, I noticed in your lecture that structural sufficiency imitates the natural environment. Should architecture students start looking more into replicating nature to create a sustainable and sound architecture?
I would say absolutely. I think there are beautiful books and articles on biomimetic architecture. It is, you know, I think the word has been so controversially used. You know, mimicking something generally doesn't seem to have a positive sort of tone to it. But it is about maybe not so much replicating it, but understanding it and mimicking its effect. I think studying nature, studying plants and trees ought to be one of the syllabus in our architectural, in our engineering schools. We understand the desired results, and then we mimic that. The way it may look in our buildings may not be exactly the same as it is in nature, but it has the same effect. It is that mimicry that is that I advocate. Somewhat controversially, I say, obviously aesthetics and looks and things. It is sort of just to provoke, as it were. But it is the desired effect that we need to understand nature. Like the most important thing about nature, you know, if you go to into a forest and talk to a lion and try to explain to him what waste is, you will never be able to do that. he would never understand it, because this concept does not exist in the natural environment. So it is mimicking that, trying to come up with something in our work that in the first instance reduces waste, and then ultimately does away with that whole concept. It is also mimicking nature I would advocate.
Well, that's the end of our discussion session. Thank you to the audience for all of the wonderful questions, and thank you to Dr. Rezai for a very interesting and engaging lecture on structures as well as sustainability concepts in the built environment. I will hand it over to Dean Curry now.
Thank you.
Thank you. Thanks, Bhavna. Thank you, Dr. Rezai. That was really an extraordinary path that you took us on intellectually and visually, and in terms of the history and contemporary history of structures. And so it's really an amazing body of work that you've produced, and the thinking that that you're working with right now, which I think is very future focused. And so we're really delighted to have had this opportunity with you. I say this to every lecture that when we're back in person, we've got to get you to LA. And I sincerely mean that. So so we look forward to that. This was an extension of some of the really interesting, engaging conversation we had when I was recently in Singapore. And I look forward to continuing to engage with you and having our students and faculty. It's really a pleasure. So thank you.
Sure. Thank you very much. And likewise, I enjoyed this engagement. I hope the students would find some of the provocations and the ideas I have raised of use. And I look forward to meeting up in person in LA or Singapore or wherever else it might be, and to a face-to-face conversation with you and to Bhavna. Bhavna, we must keep this conversation going.
Absolutely. Looking forward to it.
Thank you so much. Have a great night, everybody. Thank you.
Thank you. Thank you. Bye-bye.
Thanks, Doctor. Take care.